Okay, another day, another set of lead code questions. Let's get it. So, I am gonna start with this one today, Russian doll envelopes. So, the point is you are given a 2D array of integers envelopes where envelopes of I is WIHI represents the width and height of an envelope. One envelope can fit into another if and only if both the width and height of one envelope are greater than the other envelope's width and height. Return the maximum number of envelopes you can Russian doll, put one inside the other. You cannot rotate an envelope. So, one simple observation here is that an envelope can only fit inside another if both length and width are smaller, right? So, if I have an envelope, let's say this is 5 and this is 7, I cannot fit an envelope of 5 by 4, right? Because this will touch, right? Is it? Let's look at an example. If we have 5 4 6 4 6 7 2 3 2 3 5 4 6 7, so I believe they are strictly increasing. Yes, greater. There is no, yeah, strictly greater. So I can fit a 4 by 5 envelope, but I cannot fit a 5 by 2 envelope, right? So yeah, this is the main point here. Okay, let's take this example. Sorry, if I move it right here and make it some big. Okay, now one thing I can think of is sort them on some basis. Should I sort them on the basis of area? But that can give me a skewed thing, right? An envelope can be 110, which is equal to 52. So yeah, it's kind of sketchy, you know. Okay. Okay. Let's only sort it on the basis of length, right? So what will be the sorted order here? It will be 2 3, then 5 4, then 6 4, and then 6 7. Now I know for sure that the lengths are in increasing order. There can be duplicate, but yeah, we can skip through. Okay, now I only need to test. I should actually sort it in this way, right? I should sort L1 should be less than an L2, but if L1 and L2 are equal, then sort by width. So W1 should be less than W2. I think this sorting order gives me more accurate thing to work on. Now I know for sure that lengths are in increasing order. Now I only need to check widths here. So I just need to check a sequence of widths where it is strictly increasing. The longest okay, brute force approach is pick an envelope. Let's say this is the smallest envelope here, 2 3, right? Now I have to iterate through rest of the array and check if length is greater than the previous one. It's not strictly increasing. And width is also strictly increasing. Right. Then add one, basically pick that one, and then from that move on further. Now I don't think this will fly because this is long. Okay. I basically have to find longest increasing subsequence here. Right? Okay, longest increasing subsequence. How did I what was the technique to find longest increasing subsequence? I think it was n square, right? Yeah. So usually we assumed that the longest increasing subsequence starting from here is 1, right? Then I go to 4, I see that 4 is less than 7. So I increased this by 1, right? Max of this or this plus 1, right? So this becomes 2. Then I see 4 is not greater than 4. 4 is greater, 7 is greater than 4. So 1 plus 1 becomes 2. Now 4 is greater than 3. This becomes 3. I just have to return the max thing, right? Okay, not the envelopes that we are choosing, which is good. Okay. I believe it is longest increasing subsequence, but I am not sure if this will fly. N square approach, you know what I mean? We can try. How do you do DP on this? Is this a DP? Binary search sorting. Dynamic programming. Binary sorting. Okay. Yeah, I think this is dynamic programming, right? Yeah. Okay. So, okay. Sort envelopes dot begin envelopes dot end. Compare length then width. Now let's write this comparator, which will be a struct compare L then W. Yeah, let's make this small, I don't want to. Okay, this will be a struct, so it will be a bool operator. This const vector int a const vector int b I don't know if I'm doing this right. So if a0 is equals b0, then return a1 b1. Otherwise return a0 greater than b0. Hopefully this is correct. I'm just checking the syntax here. This won't be allowed for sure. Compare L and W sort. What? It's a struct, bro. Have I fucked it? Does not refer to a value. Am I doing a poo-poo here? Oh, this is a priority queue, man. What the fuck are you doing? This is for priority queue, not for this. Shit. So, is it just this? Well, I would have failed the interview here if it was a real thing, you know. Damn. I am cooked, bro. Okay. So just this. Okay, now these are sorted here. Now int n equals envelopes dot size vector int lis n1. Now lis should be done on no, it's just one thing, right? Yeah. Okay. So for int I equals n minus 2, I is greater than equals 0, I minus minus. For int j equals I, j is less than n, j plus plus. If I have to compare I and j, right? If, right? Yes. Should be I plus 1, right? Yeah. So if n envelopes of if envelopes of I length is less than envelopes of j length and envelopes of I width is less than envelopes of j width, then I have to update lis. Lis of I becomes max of lis of I and 1 plus lis of j, right? At the end I have to return lis of 0. Oh, I have to return the max value obtained. So max res 0. I have to update here. Return max res. Okay, wrong answer. 0 0. What? Maybe no. What? It should be 1. Yeah. Let's see if this works. This is a hard problem. I'm not sure that this will work. I don't know, bro. Yeah, that's what I expected. So the time complexity of this is n square for sure. N square plus n log n. So yeah, n square. Now can I do some caching here? But yeah, I don't know which envelopes I have picked already, right? Okay, let's take a look at my past solution. Compare the width. If width are equal, then arrange in descending order of height. Arrange them in descending order of height. What is this? What? Then arrange them in descending order of height. Ooh. Arrange the envelopes in increasing order of width. If the width of two envelopes is same, then arrange them in descending order of height. Why? To disable them to be added to the longest increasing subsequence. Yeah, I need basically it means that we need to make enough, we need to keep the most largest envelope, right? Because we cannot fit envelopes inside one another having same width, the bigger envelope has to be strictly greater than the other one. The bigger envelope has to be strictly the bigger envelope has to be strictly greater than the other one. Then I them in descending order of height. Okay. Sort. Maintaining a sorted sequence of height. What? Sort envelopes. Okay. Sequence dot pushback. For I equals 1 I is less than n. We have pushed back what? 0th envelope and first one. What is this? 0th and the okay, sorted sequence of height. Okay, these are width and height. Okay. Wait. Sorted sequence of width and height. So we are storing height here. Now, okay. We know for sure that the width is always strictly increasing. Okay. We start from 1. Current envelope height is envelopes of I1, correct. Last sequence envelope height is sequence dot back. Great. If current envelope height is less than or equal to last sequence envelope height, if current, it means that it cannot fit, then int index equals lower bound. We are doing a binary search sequence dot begin sequence dot end current env height minus sequence dot begin. Okay, what does lower bound do again? If I do this, then does it work? I don't know, man. This won't fly, man. There is no way this flies. Okay, let me ask ChatGPT. What is lower bound in C++? It is used to find the first position in a sorted range where a given value could be inserted without violating the order. Can you explain this in fucking simple terms, man? So begin and end, value to compare. So 10, 20, 30, 30, 40, 50. You want to find the first number in the list that is greater than or equal to the number, say 30. Okay. Greater than or equal to. And the upper bound is, I think, strictly greater, right? Strictly greater, and this is greater than or equal to. Okay. Why does it say like what the fuck is this without violating the order? Just confusing me. Okay. Lower bound is greater than or equal to. So we search in sequence the current envelope height. We are basically getting the index of that, and then we are updating that current env height sequence. Else it means we can push this, then sequence dot push back current env height, return sequence dot size. But the point is there can be multiple these things, right? If only if both the width and height of one envelope are greater than the other envelope's width and height. How does it satisfy this condition when the width of both are same? Then I need them in descending order of height. Why? To disable them to be added to the longest increasing subsequence. If width is same, but if width is same, then height in descending order. So okay. When width is same, it means that the current env height will be greater than the last. Bro, I don't understand this. You know what? We can let's do a dry run in here, man. Fuck this shit. So we have this code, right? Now let's have an example. Okay, yeah, width width is same, then we sort it based on descending order of height. So first we do 2 3, which is easy. Then we have 5 4. Then we have 6 4 and 6 7. Now width is same, but we put 6 7 first in descending order of height, and then 6 4. Then we have a sequence right here, which is empty currently. We sort done, sequence dot push back. We are pushing the height, so 3 is pushed here. Then we check current env height, which is 4. Last env height is 3. If current env height 4 is not less than or equals to this, then we push 4. Now current becomes here. Now we see 7, right? Current env height is 7. Last sequence env height is 4. 7 is greater than 4. We push 7. Now current is this. Now we see that 4 is less than or equals to 7. Then what do we do? Okay, we are basically replacing it in the sequence. So yeah, this guy, okay. So we are searching here, lower bound, sequence dot begin, sequence dot end, current env height. We are searching for 4 in this sequence. in a binary search way, such that 4 is greater than or equal to the value. So we get this index, which is 1. So we replace this 4 here. Okay, so this is kind of a gimmick. I mean, yeah, doesn't it doesn't really make any sense, but it does the job of calculating the max envelopes. Yeah, I guess. 354. Let's ask this guy. Can you solve and explain lead code 354? And okay. So what's the point of this DP? Where height is strictly increasing. The DP array is used to track the LIS of envelope heights. We're not tracking the actual sequence, but it's like using greedy plus line. Okay. Yeah. So yeah, this doesn't, I mean, it's not, yeah, it is kind of, yeah. Okay. So vector of int sequence. Push the first height to sequence. Sequence dot push back envelopes of 0 and 1 for int I equals 1, I is less than n, I plus plus. Int current height equals envelopes of I of 1. Int last height equals sequence dot back. Right. If current height is less than or equals to last height, if current height is less than or equals to last height, then int idx equals lower bound. Yeah, this is one of those questions, if you don't know the solution, there is no fucking way you can do this thing. Like, yeah. I mean, I came up with the brute force approach, but apart from that, it's just fucking nuts. I have to search for current height. And I have to get the index, so I have to do First of all, this should be searched on sequence dot begin. Then sequence of idx equals current height. Otherwise, just push to sequence. At the end, return sequence dot size. Hopefully this satisfies leetcode gods. Of course. So yeah, this is one of those questions. It's just, you have to know to solve this thing, man. There's no other way. Yeah. Okay, no worries. And let's check if leetcode had this one. So this was 1DDP. Nah. 2DDP. Nah. 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 Let's see if this was in all. This should have been in 1DP, man. Russian doll envelopes, yep. Okay, so I believe my next aim should be to solve these or 250. Let's start with 250 first, and then we move on to the neat code all thing. Okay, let's do this shit also. Yo. Course schedule 2. I don't know what this link is. This can be some bad stuff here. There are a total of num courses you have to take labeled from 0 to this. You are given an array prerequisites where indicates that you must take course BI first if you want to take course AI. For example, the pair 01 indicates that you have to take course 0. Indicates that to take course 0 you have to first take course 1. Return the ordering of courses you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all courses, return an empty array. This is straight up topological sort. There is nothing else to do in this question, so let me just possible by partition. You know what, let's warm up with this topological sort and then we get to the last question, which might be the hardest. Okay, so topological sort is I do it using the in degree method. So I first calculate the, let's rename some variable. This is just n and this is just pre indeg n 0 for vector int p in prerequisites in degree of. In order to take course 0, you have to first take course 1. So 0 has an in degree of 1, right? In degree of p of 0 plus plus, right? And I believe I also need the graph, so it's just vector of vector int graph of size n, right? Graph dot push, sorry, so there is an arrow from 1 to 0, right? So graph of p of 1 dot push back p of 0, right? VS says yo brother or sister. VS, I don't know, bro. Okay, now I have to calculate I have to find out which node has 0 in degree. Then I have to start with that. So vector int sequence. So it's like my life be like ooh ah ooh, while true. Randomly found this live, lol. Cool. YouTube algorithm is working as I don't know, bro. I mean, yeah, it's just YouTube, man. Okay. Find out the node which has 0 in degree. So for int um I or n in sorry I in degree start equals -1 if I is equals 0. Yeah, I mean there can be multiple starting nodes, so I need to push both of them in sequence, right? Yeah, there can be multiple starting nodes. So I just simply push sequence dot push back I. Is it? This is just bad, bro. I equals 0, I is less than n, I plus plus. In deg of I is 0, then sequence dot push back I. Okay. Now, for all of the nodes which are in sequence, I have to just decrease the in degree, right? How do I do that? Do I need to do some sort of BFS? Maybe. Yeah, maybe BFS is needed. And instead of this, maybe we need a Q. Q. While Q is non-empty, get the size of this Q. While size minus. Rubbled man, sup bro, what's up? Dev Malik, yup, yo brother. Okay, while size minus, get the current node, q dot front, q dot pop. Now for current, for every neighbor of current, decrease the in degree of that neighbor. So for int neighbor in graph of current, in degree of neighbor minus, if in degree of neighbor is 0, then q dot push neighbor. And we can push this to sequence also. So we need two things here, sequence and q. And this should be q and sequence dot push back I. Would you mind if I ask your opinion on something? No, I won't, brother. Well, it depends on your question. I push that neighbor to the queue, then I push that neighbor to the sequence also, because the in degree is 0 now. This feels very bad, man. So if in degree of neighbor is greater than 0, then we subtract and do this shit. right? Sequence dot pushback. Yeah. I completed my undergrad last month. Been interning at small firm as an SDE. Okay, that's cool, man. That's good. Good to know. Okay, let me just check. Okay, Q has those two subjects there. Then we get the size. We get the current one. For every neighbor of that current, we decrease. If in degree of that neighbor is greater than 0, first of all, we decrease the in degree if it reaches 0. Then we push that to the queue, and then we push to that sequence. And we are popping every time. Right. Return sequence dot size equals n question mark sequence, otherwise an empty list. What? Sorry, brother. I don't know. I didn't know that C++ is a pussy language. Okay, it accepts. Yes, I am still worthy. I still can do graph problems, at least the medium ones. Let's get straight to number 12 because I am too sick. I'm just too sick. Now see me failing this question in a pretty bad manner. This question is okay, still a medium question. Okay. This list maybe is a poo-poo, I don't know. We want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people, and they should not go into the same group. Given the integer n and the array dislikes, where dislikes of I, AI, BI indicates that the person labeled AI does not like the person labeled BI. Return true if it is possible to split everyone into two groups in this way. My primary stack is Python, Flask, Django, and all I do here is just sending postman request and verifying it. I feel like I am stuck here. Okay, so you're probably building a web application, and okay, I feel like I'm stuck here. So okay, why do you feel stuck? Do you think that the job that you are currently doing, or the stuff that you do at your job, you know it already? I mean, you know it pretty well, like making a web application, how it functions and stuff like that. Do you know that already? Like, can you make any web application using these techniques that you follow? I mean, the point is, you can learn anywhere. You can learn a new technique. You can optimize your, workflow. There is always something new to learn. But if you are feeling stuck, just grind LeetCode and apply to jobs, brother. Just like everyone else and me. That's how to get money and pussy, I mean, that's how we all do development, right? We just write code and use Postman or any other software, or just curl requests, and then we write unit tests, and then we claim it that we did test driven development, which is completely opposite that we just did. So yeah, it's same everywhere. It's same. If you are a web developer, it's the same thing. If you want to try something else, just learn new stuff and get a job there. But ultimately, it's all about money and pussy and weed. That's how it is. Okay. So the point of this question is we are given a dislikes array. So AI doesn't like BI. Return true if it is possible to split everyone into two groups in this way. So 1 doesn't like 2, so 1 and 2 cannot be in the same group. 1 and 3 cannot be in the same group. 2 and 4 cannot be in the same group. And we have to keep two groups, right? We want to split a group of n people into two groups of any size. Okay. Is this like a union find stuff? Or a bipartite graph? The first group has 1, 4 and second group has 2, 3. Yeah, it feels like a union find shit, you know? I don't know, bro. Is this union find? Yeah, can be union find. DFS, BFS, graph. What does this guy say? Graph coloring, union find. Graph coloring. How can I do graph coloring here? So I know number of nodes. I have to color these into two things and make sure that these two are not colored in the same way. Interesting. You know what, let's just revise union find using this problem, and yeah, we can write union find class. So the point of union find is to write this class in the most efficient way as possible. So what does union find have? It contains I don't know what it contains. It contains two things actually. It contains n, right? And it contains a vector called parent, right? What does it have? What else? Yeah, I can keep track of size of components. So vector int size. And my power is gone. No worries. I will continue the stream, man. No worries, man. Okay. Okay. What else do we have? And we have two functions, union and find. So find actually returns the parent of the given node. So let's say if I'm given a node, it will return the parent of this node. And let's also write a constructor here. In constructor, I'm just given n, so yeah, this n equals n parent dot resize n 0. Sorry, so yeah, this should be size, and initially the size of each component is 1 because every node is by itself. And for parent, I can do this shit, parent dot push back I. Okay. Let's not do some recursive bullshit here. So while int current equals node, while parent what the parent of current is not equals current. While parent of current is not equals current, current equals parent of current, right? Now current will be at the topmost level, right? Then we need another loop. This will be path compression. Shit int next equals parent of node. Okay, I'm taking too much time writing union find. When will I do this question? Good point. Parent of node equals current equals next. So this step is known as path compression. At the end we return current. Now in union we say we have two nodes P1 and P2. If find P1 is equals find P2, then return false. Returns false if both nodes are in the same component. You know what? Let's call them N1 and N2 because this is just confusing at this point. And the parent are called P1 and P2. P2 equals find N2. Now we can simply say if P1 and P2 are equal, then return false. Otherwise, we have to unionize these guys. And the strategy that we will use for unifying these P1, N1 and N2, it will be if size of P1 is greater than size of P2, else size of P1 plus equals size of P2 and parent P2 equals P1. Otherwise, size of P2 plus equals size of P1, parent of P1 equals P2. Parent P2 equals P1. This is correct, right? P2 parents is P1. Yes. And at the end, we can simply return true. Hopefully this will give me the stuff. Now here in this question, what we need to do is n can be 2000. Let's create a union find uf equals new union find of size n. And okay, so since these start from 1, that's why I'm doing n plus 1 here. Now for vector int D in dislikes. Hmm. 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 Okay, 1 and 2 cannot be in the same thing. So how can I use union find to make sure that these two don't end up in the same thing? What? Currently everything is on there. Okay, maybe I did a poo-poo. 1 and 2 should not be in the same group. Why is this size? What? Shit. This should be SZ. Or let's make it size is. Because size is a keyword, my friend. Okay. What the fuck? Okay. How do I use union find now? Dislikes 1 2 1 3 1 4. Oh, sorry, 2 4. Okay, maybe I can do some shit like P1 is dislikes 0 0, P2 is dislikes 0 1 for int. Now P1 and P2 are two groups basically. Okay. Yeah. Now if I get another group, then now I okay, two groups. Now here I have to check if okay, 1 and 2 belong to two different groups. Let's take this fucking example, man. Copy this shit to here. 1 and 2 are in two different groups. Now I have 1 and 3. Now I have to check first of all if 1 and 3 belong to the same group. If they belong, then return false. If they don't, then I have to put 1 in either P1 or P2, right? I mean, okay. If yeah, I can put 1 already to 1, right? I can't put it to 2. Uh, hmm. I have to check if parent of 1, if okay. First of all, I have to check if 1 and 3 belong to the same group. No. Then I have to check if parent of 1 is itself, right? If parent of 1 is itself, then I don't need to do anything. Now parent of 3 is itself. Parent of 1 is itself and is equals P1. Parent of 3 itself. Now if 1 belongs to P1, 3 should belong to P2. Right? Bro, this question is fucked, man. I can't figure out the last point here. Let's say 2 and 4 come up, right? If this was an interview question, I would have lost at this point. So yeah, if find n1 is equals find n2, then return false. If find n1 is equals find p1, shit. It should be UF this, man. I have forgotten C++. Union N1 P1. Okay. Else if N1 is not part of P1, else it is part of P1. You know what? Let's take a look at this fucking solution. I have solved this already. What the fuck? Using BF. Okay, possible. Okay, create a graph. Create a graph of dislikes. They dislike each other, so it is an undirected graph. Now in colors. Okay, colors. N plus 1 minus 1 for int 1 to n. If colors is uncolored and BFS util is not, then return false. And then what does BFS util do? Graph n source colors. q dot push source, colors of source is 1, so we are coloring the source as 1 while q is not empty. Next color, if current color is 0, then next color is 1, otherwise it is 0. Current equals q to this, current color equals colors dot color. What? Current color. Yeah, makes sense. Go to neighbors and assign next color for each neighbor. What? Okay, you return power. Okay. Okay. So, yep. So my question is, why aren't we doing level order traversal here? Doesn't it make sense to do level order traversal, or am I tripping? Right? Yeah. Okay. Let's take a look at solution using union find. Do this union find DFS BFS. Most votes. Let's get this. Typical, but when union add an if statement to check if parent of dislike node is same. What? Okay, they have created a graph. They have created the UF. So okay, graph created. Then from this to this. Oh. Okay. Okay, makes sense. If parent of I is in self dot graph parent dislike I. What the fuck? Can you just do it in fucking C++, man? Please. Please. Okay, so the point is, instead of doing this garbage, just traverse over n for int I equals 1, I less than equals n, I plus plus. Do I need graph? Yeah, maybe. I don't know. No, man. Shit. Maybe I need to create a graph, man. Fuck it. Fuck this shit. Vector of vector int graph n plus 1. Graph of d0 dot push back d1 and the other way as well. Okay. Now, what do we need to check? I need to check the neighbors of I, right? For int neighbor in graph of current. Neighbors or this. If neighbors are continuous, if first neighbor gets the first item in the set. Oh. for int neighbor in neighbors. If current and neighbor are connected, then return false. Otherwise, yeah, makes sense. This is, yep. Makes sense. Okay. Yep. Current. Okay. So if uf find current is equals uf find neighbor, then return false. Shit. Let's see if this shit works. Oh, what? Bool union. Declaration of anonymous union must be a definition. What? Unify, you mean? And this is public. Public. And this will be unify, my friend. Let's see. Okay, works. Yeah, I wasn't able to get. Yeah, it's whatever, man. Shit happens. Okay, time limit exceeded. What the fuck? I'm doing path compression also. Why is it exceeding? What the fuck, man? What the fuck? What else is there? Do I need to keep track of visited and shit? I don't know. Let's take a look at this guy. Okay, set of this if first neighbor of this. For int in neighbors. If UF is connected, then return false. Is connected. Yep. Parent. Yeah, maybe this is expensive. 2 while loops is crazy, bro. Why can't you do just fucking one thing? Okay. If parent of node is equals node, return node, right? Int root equals parent of find parent of node, parent of node equals root, return root. Let's see. Livy X, hello, what's up? Yeah, this find function was brutal, man. Yeah, this works. Cool. Okay, so yeah, this 12th question, yeah, absolutely obliterated my confidence with graphs. So yeah, I will be back on graphs tomorrow. Yeah, I just need to cover a lot of stuff tomorrow, man. Not tomorrow, just today. I have entered 30th June. Cool, no worries. So I'll just get some sleep, get through my work tomorrow, today basically, and then tomorrow I have an interview which I need to be prepared for. Okay, so yup, I'll just bookmark this shit. Alright, I'll see you guys tomorrow, most likely, or I mean today. Until then, have a good day and rest of the week. Alright, GG's.